Cool. Well, you guys are diehards. Last session of the day, last day of the conference. So thank you for coming. I hope there's something useful you'll get out of this. It's been fun to put together. So my name is Mike Smith. I'm a cloud architect at overstock.com. We've been running OpenStack since Folsom. We currently have 5 different OpenStack clouds in different areas that we run our production as well as our development and test, staging, that kind of thing. Most of our production infrastructure is virtual these days on OpenStack. And I just wanted to talk a little bit about kind of our experience in transitioning from a legacy Ceilometer using MongoDB into a more current one running Gnocchi as a backend data store. Are there any Gnocchi or Ceilometer contributors that are here with us today? Just curious. Okay. If not, I was going to call you guys for help on something. But that's cool. If you're watching this video later and you want to get a hold of me, please do. There's my address on the screen, and we'll go forward. So it seems like forever ago, but in the Austin Summit, I gave a talk about using Ceilometer not just for elastic scaling and things like this, but also for what I call witch hunting. That's me. The idea of using Ceilometer for witch hunting is basically when things go terribly wrong, like in this scenario when your load spikes up, trying to figure out who the noisy neighbor is, who is the guy that's doing all the traffic, causing the chaos, so that you can bring them to justice or consult with them in some way so that you can resolve the problem. So that's what the talk was in Austin. We talked a little bit about how we know that there's a problem, as well as the advanced science behind figuring out who that person is that's causing that. But we're not going to talk about that today. We primarily have a use case at Overstock for Ceilometer and Gnocchi, using it for elastic scaling. We do it kind of in our own homegrown way, not necessarily using heat, because we don't use heat. But this is just an example of a Ceilometer alarm that, oops, wrong button. Ceilometer alarm that's posting to an API that we run in-house, and it's telling us to scale up a certain cluster when this alarm passes a threshold on CPU utilization. So we have lots and lots and lots of these. We have about 800, 900 different applications that power the Overstock website. And each one of those services can scale independently as needed, depending on the load that's coming in at the time. So we make extensive use of Ceilometer and its ability to trigger based on CPU thresholds and memory thresholds, things like this, hitting our own in-house orchestration APIs to cause that scaling up and scaling down. So when we get a request like that, our tools receive this request, and they also kind of walk it through a variety of steps, making sure it's in Puppet, making sure it's passing in our monitoring. For example, we don't want to be alerting people that are on call that a service is down if that service was just born and just hasn't come up yet. And so we have a bunch of stuff baked in there to do checks for these kind of things. We call it auto checklist. It goes through these, and when it's successful, and the whole, this code is called Elastigirl. She notifies us via Slack what she's up to. She's probably the hardest working member of our cloud team, and builds things, tears them down all day long. And if one of these things doesn't pass our checklist, maybe it never got added to a load balancer properly because its API was down, or it doesn't pass a health check in some way, she'll tear it back down, which is kind of a nice sanity feature for us. So this is our primary use case for Ceilometer, and this and the ability to track down noisy neighbors. We have some web UIs that we've built for our operations teams that they can go in and, talking to the Ceilometer APIs, they can go ahead and adjust these thresholds on a per cluster basis. This one's showing Club O, which is our rewards program for customers. And they can dial up and down the number of instances that are needed for Club O and decide how many minutes of high CPU threshold have to pass before this happens. So they don't have to get on the command line and deal with Ceilometer alarms at that level. They can do it through this UI that we've built for them. So Ceilometer worked really great. This was mostly in our Kilo cloud last year at the time we were giving this talk at Austin Summit. But it just didn't quite scale the way we needed it to. Mostly it was around Mongo replication lag, and the time you start adding more and more metrics, it takes more time to sync up, and we would get a lot of alerts for Mongo replication. The other side of the problem was that when you go to query that information, it could be very, very, very slow, especially when you're trying to find noisy neighbors. That can be a problem because you've got a big load spike, and you need to find out now who is causing that. Makes it a little bit difficult when the query time is very slow. So, in the midst of all this, every 6 months the OpenStack user survey comes out, and one of the questions that they had right up front is this one. Are you still using, if you're using Ceilometer, are you still using the legacy MongoDB, or are you using Gnocchi, or are you using some of the others that they put in there, Kafka and some other things? So clearly they want us to move away from legacy Mongo. I don't like running anything that says legacy. So we started looking at, would it be feasible for us to move to Gnocchi? Now, we weren't ready to go to a new version just then. The latest we could possibly go to was Newton when we were looking to do this. But this was the result, from Julian Danju, who's involved in the development of this Gnocchi, that he's sharing with the mailing list about how many people are running legacy MongoDB. In this case, from that survey, I think this was back in February, that the majority are still running legacy Mongo, but more and more people are moving to Gnocchi. So that was encouraging. We saw a lot of discussion about people moving and wanting to move, a lot of advice saying you should move. So we started down that road. So lots of Googling on Gnocchi. Great, let's do it. We got a brand new cloud we're going to set up. It's on Mitaka. Let's go for it. First thing that comes up typically when you Google for Gnocchi is their homepage. And it's okay as far as documentation goes. It's not, from an operator standpoint, and somebody who lives and breathes by the docs.openstack.org site like me, it was not quite as detailed as I would have liked it to been. It talks about installing with pip and mostly around DevStack, maybe OpenShift, Docker, these kinds of things. But very different from the full-blown documentation that is on the openstack.org site for the rest of the services. So, okay, a good starting point. Here's another one thing we came across in the documentation. This is a presentation Julian put together for a OpenStack Days in France in 2016. And looked real encouraging. It has a lot of scaling information in it, how it's performed pretty well. And this one was of particular interest because they have a policy of if you don't document, you don't get a merger code, and that sounds great. So we continue to look for that documentation. So as we go to set up our Mitaka cloud, it's time to install Ceilometer. We say, great, what's in the Mitaka install guide? In Mitaka, the default is still install and configure MongoDB. Okay, that's where we started at. So we installed our new Mitaka cloud, Mongo, legacy Ceilometer. It's all in there. Great. Looking to see if we can kind of glean some information out of Newton. Newton still has you install Mongo. And it wasn't until Okada that the default becomes Gnocchi there. That's great. So it talks about it being recommended at this point, and to enable it, we just have to go and see its install guide. So we're getting somewhere. It's all very exciting and encouraging. We click through that install guide, and we're back here. Okay. So Gnocchi is a project outside of OpenStack, as I understand it. It works well with OpenStack. It was born in OpenStack, but it is managed as a project outside OpenStack. From an operator standpoint, the documentation was very difficult to find how to do what we wanted to do. Mostly talks about DevStack and running it as if you were a developer. Got ahead of myself. So we began a quest of figuring out how we could take our running Mitaka cloud, put Gnocchi on it so that we could get some better performance on it. And here's a little bit of a dramatization. I had a young lady named Tracy that was working for me at the time, and that was one of her first assignments I gave her was to, hey, go figure out how we can do this. So here's kind of a recreation of how that discussion went. Okay, so that's about as far as we got there. That discussion really happened by way of a JIRA ticket, but you get the idea. So it was not very easy to find operator-oriented documentation for Gnocchi. So many, many, many Googles later, different keywords, different incarnations. One day, I stumbled upon this one. And, Ceilometer, Gnocchi, AODH, it talks about CentOS, it talks about RDO, it talks about all the things we run. It was this holy grail that we encountered. And it was very exciting, and this is the page. I don't read, I assume this is Mandarin. I don't read Mandarin. My kids dabble in it. But this literally was the most helpful document on the internet that I was able to find in about a week's worth of searching. And it really has everything in it that you would need. I can't read the headings, and I'm very grateful for whoever took the time to blog about this. You can find it. It comes up several pages. I'm sure I glossed over it originally because it was in Chinese. But it talked about enabling the configs the way you need them. It talks about how to do these archive policies. These archive policies are a new thing in Gnocchi compared to legacy Ceilometer. They don't exist there. And it was very difficult finding how to do that. The other documentation we found led you to believe they were pre-populated, and the syntax, even today in the command line, it's not very useful to describe how to create these archive policies. You kind of have to stumble upon this page to find it. Okay, so that's really what was the holy grail of allowing us to do it. So this is my heartfelt thanks to the person who wrote this blog in China. So if this is what we had before in our Mitaka cloud, and to go through this, we're basically running Ceilometer compute and other polling agents that put this information into a RabbitMQ queue here that a notification agent pulls and consumes, then puts it in another queue, which is consumed by the collector process, which then puts it into, in this case, this was MongoDB, where it's then evaluated and alarmed upon. And we were able to move ourselves to this, which is exactly the same thing, except in the newer model, all of your measurements are stored in Gnocchi as a web-based API and its back end of storage, and the events are the only things that are stored in the SQL. In the first half of converting over, we found that we still had to run Mongo, even though it wasn't being used at all. If we tried shutting it down and you started up the Ceilometer processes, it would try to talk to a Mongo that didn't exist. And again, it was that China blog that helped us find the specific tweaks and settings that were needed to make that move to our MariaDB. So this is where we landed. And so I can say, yes, it is possible that you can run Gnocchi with Mitaka. You can run it with Newton, which we're doing now on some other clouds. And you can even remove MongoDB if you find the right sauce to do that out there. But there are a lot of scalability issues. It's not that the scalability issues went away. There's just very different scalability issues. So I hear that a lot of these are improved upon and much better past Newton. I haven't been able to go there yet, but I do look forward to that. So I'll talk a little bit about those. We mentioned the trips that these messages take through various rabbit queues. Ceilometer compute puts it into notification sample. Ceilometer notification pulls it out of notification sample and puts it into metering sample. And then the Ceilometer collection agent takes it and publishes it to the Gnocchi API. So what we found is when we enable a lot of metrics, like we would like to collect, we had so many messages flying through our queues, we just had to back it down because we just had a huge backlog of rabbit messages. So that was, unfortunate for us. This is actually something I took this morning. This is our current backlog of Gnocchi metrics to process. I mentioned before that legacy Ceilometer is very slow to query on things, and that's because it is having to do the calculations on averages and statistics and things at query time, where Gnocchi does all of that as it's being ingressed and ingested into the system. So it does all these transformations and calculations and stuff there as it's coming in, which is great, but it does take a lot to process. So Sometimes you will have a backlog depending on what's going on. And when you're trying to evaluate scaling and elastic growth minute by minute by minute, it's kind of not good to have a backlog. So we've had to adjust and add additional servers. So one of the first things we did was immediately move all of the Gnocchi processing off to its own set of servers. And this is what this morning's load average on those Gnocchi servers looked like. We're running with 50, 60 average load averages on these things. Now, they have CPU, they can handle it, and they're not doing anything else, so I'm happy to keep them busy and keep them as hot as I need to. But just in comparison to our other hosts, where we have controller hosts and we have compute hosts, and even our compute hosts run at most like a load of 10 compared to what we're running with Gnocchi with a load of 60. So this is running with the recommended Ceph-based Rados object store for storing these metrics. We also tried at different times running it over NFS, which was terrible as far as performance goes. This load got into the thousands. It is a busy, busy beast when it does this. Okay. Another thing, it has this thing called a metric coordinator, where you can use a file, you can use, in future releases and more current releases than what we run, you can use Redis and Memcache and things like this. For what we're running, the MariaDB or a file are kind of the two options you can deal with. The Memcache was supposed to work, but we couldn't get it to work right. But what this did is this results in a whole lot of MySQL connections coming through, 173 a second, 1,000 open plus. And it's this coordination to make sure that the nodes don't stomp on each other as they're processing these metrics. So currently, we really kind of have to limit ourselves to just collecting CPU utilization metrics. We would love to collect a lot more memory and network and disk and all of this. But if we dial up those metrics, we find that our rabbit queues can't keep up. We find that the load on and the backlog on Gnocchi gets pretty bad. The worst thing is we were humming along pretty well, and we're using Ceph for VMs in a VM pool and a volume pool. We're using Gnocchi metrics in Ceph, and it's in its own pool for metrics. But after a recent Ceph upgrade, it was just a minor upgrade as well, suddenly we had VMs get locked, and Ceph started tanking. And what we found is that there is some known bugs about the sheer volume of Gnocchi objects that it stores in Ceph as object can really impact your other pools, even though it should not. There is a currently open bug, that talks about it, creating so many objects that it causes this problem. Looks like Julian has assigned this, and that it was targeted for Pike. There is also, if you follow that bug, you'll find this article from Red Hat that talks about tuning Gnocchi and Ceilometer for scale. There is a whole lot that you can adjust. We're just getting into it. There's batching, there's how many workers you run, and there's a whole lot of combinations that can be run. The more worker nodes you run for processing the metrics on the Gnocchi hosts, well, the more load you're going to drive up on those hosts, but the faster you're going to process them. So there's a whole lot of config options that you can tweak and change. Several of them are mentioned in this article. The result of this article is basically keep an eye on it and tune it as best you can, is what the answer to this particular article was. So we're watching for that bug to be fixed that I mentioned. We're watching for how it works in newer releases of OpenStack and even newer versions of Ceph. That's one of the reasons we run totally separate clouds for different things instead of one very large cloud, is it lets us test different versions of things like this. So that's kind of where we're at. I mentioned Gnocchi archive policies. The way these work, and the three that get populated, not really by default, but that are recommended if you follow that Chinese blog, was you have a low, a medium, and a high, and it really comes down to what granularity do you need, how many of those do you need to keep. So we used medium, is what most of our stuff started out as, which means we're keeping a day worth of per minute metrics. We're keeping a week worth of hourly metrics, and we're keeping a year worth of daily metrics. Okay, so and not only that, but we're also doing the standard deviation, the number, the 95th percentile, min, max, sum, median, and mean. So, that's where we started. As we got into it, we kind of made our own that we called medium rare, and all we did was dial back the number of data transformations that we were doing. So min, max, median, mean, we don't really use the others, so that was fine. That helped us with our load a little bit. The week before I came here, we were almost to this point where I've created this one that all I care about is my hour of minute-by-minute metrics. And we'll probably switch over to this and see if that will help bring us down, the loads down. Part of the problem is when we have holes in the metrics. And if we're trying to evaluate those alarms before those metrics come in and get processed, then there's a hole there. And that can cause some false alerts of triggering our scaling API to build and remove when we don't want them to. So that's where we're at now and some of the additional things that we're trying. Okay, so the other thing we've looked at is it possible to bypass some of those queues? We had read about this. There was talk about you can, instead of putting notifier in your pipeline YAML, you can put Gnocchi or you can put direct. And that sounded great. I had understood that to mean you could take your compute node and you could point it there and it's going to bypass Rabbit altogether. Kind of. So what we found is we could, in fact, eliminate one of those two queues, and instead of it going from notification sample and then into metering sample and then getting posted to the Gnocchi API, we can bypass one of those two and get it posted straight there. The way that's done essentially in your pipeline YAML, and this didn't originally work in Mitaka. Somebody was good enough to backport it once it hit Okada. And this publisher here, instead of notifier, it says Gnocchi, and that will post it straight to the Gnocchi API. We've done this in test. We haven't yet put it in our production, but that's for next week. And that does get it to where it needs to go. So what I had understood on the mailing list was that people were putting this kind of a thing in on their compute host and bypassing Rabbit altogether. That was not the case from what we understand. The Gordon Chung is a guy on the mailing list that is pretty active on the mailing list. And this was his response when I wrote to him. Originally saying you can't change publisher to Gnocchi in Mitaka. It was done in Okada. They did end up backporting it, so that's nice. I know it also works in Newton. And about trying to push it straight from the compute agents, there's a lot of transformations that have to happen in the notification agent. It would be great, but it's not in the code, and they really just don't have the resources to implement that kind of a thing. So that's a place that we would love to have it bypass Rabbit altogether. Just pound that Gnocchi API straight from the compute host. That would be great for us. Then you could scale it out as needed. But that's what we found, so we thought we'd share with the group. It's not all bad news, though. There is some really, really good stuff with us having switched over to Gnocchi. Primarily, those calculations, when you request, are very, very fast. All of that data calculation has been done for you in advance as the data is ingested in. And that was the original problem we were trying to solve, was to make it not be so slow and to get MongoDB out of the equation, because we had no other reason to run it. So that part worked really well for us. And as a bonus, there's actually this really cool Gnocchi Grafana plugin. So if any of you guys use Grafana to pull data out of Graphite and do some visualizations of metrics and this kind of a thing, there is a plugin. And in our Graphite, you'll see it there. And you configure some things, plug in some data, and voila, you can generate cool graphs. This is something being rendered from Grafana from our in-house UI that's calling it. And this is kind of the front end to that tool I was talking about earlier, where our operations folks can get in there and they can change the settings for what we call Elastigirl, and they can adjust how those thresholds work. The cool thing is you can pass in some information, and these lines that are showing red zones above and below the green zones, and essentially those are the areas where we will trigger the creation or the deletion of an instance. Those are kind of generated real time in this graph. It's pretty cool. You can do some pretty cool stuff with that plugin. So I really like it. Each one of those green bars, the way we're showing it here, is a minute by minute by minute by minute CPU utilization for the last 3 hours. Very quick to come up in a UI, something we couldn't have done prior. So that really concludes where we are with our quest so far. We would love any tips for somebody who's gone down this road and has had success in tackling the performance and scalability with Gnocchi. And we would be happy to share what we've learned in more detail with anybody who wants to reach out. So there's my email address. Thanks for your time. Do you guys have any questions you would like to ask before we send everybody home? He's gonna bring a microphone to you real quick, just so that we can capture it for the video. It won't catch it. Thanks.
Thank you. So it happened that I'm currently deploying a setup that have Ceilometer and AUDH and Gnocchi. Yeah, but we got some warnings from our system integrator that with the amount of matrix required from Ceilometer, the solution itself will not scale. So do you think that the bottleneck is in Gnocchi or in Ceilometer?
I haven't seen it be in Ceilometer other than the queue that I'm talking about, because those queues are technically part of Ceilometer. So I could see where that's a bottleneck. Comes into the queues, various Ceilometer processes have to ingest and consume those, and then it goes to the Gnocchi API. The bottlenecks we've seen is what it's doing to Ceph and what it's doing within the Ceilometer queues.
But what do you recommend? For example, in an NFV environment, we need to get a lot of metrics from Ceilometer. And I think we are exposing like some sort of northbound for Gnocchi, and our OS systems are supposed to get this kind of metrics. What I heard here like in the summit that Ceilometer was not made actually for performance. It's like for billing.
Yeah, it is. It's a metering tool.
Yeah, so I shouldn't expect much, but there's the fact that we need a lot of metrics, not just CPU utilization. Yeah. So what do you think, what's the best solution? How to take these kind of metrics from the infrastructure to northbound systems?
Yeah, I think Ceilometer will get there. I think Gnocchi will get there. I'm very anxious to see what it's doing in some of these newer versions like Pike and Queens that I haven't been able to look at yet. I don't have a great answer for you. Most of our metrics outside of OpenStack all come from things like Diamond, and we push them to Graphite, and those tools work really well. As far as your specific case, I don't know exactly, but I will keep looking as well. Okay.
Thank you.
Thanks. Sure. Any other questions that you guys have?
How can I improve the performance when I combine Ceph and Gnocchi?
That article that I showed with the Red Hat talks a little bit about that. We were having perfectly good performance with Ceph and Gnocchi until that last upgrade. We're running Joule, and it was like the last minor upgrade that was deployed for Joule kind of really killed us there. So I don't have specific recommendations for you other than there are articles out there I've seen that talk a lot about what you can do within Ceph to optimize it. We've started that process. We're still looking to see if that's going to work out for us. I think this bug that I showed you there, what version of OpenStack were you working on? Just depending on if that one is affected by that bug, that's a big one. So, cool. Yeah.
So sadly, I don't speak Chinese either. If I were to do this myself now and Google it, would that still be the best results, or have you put up something in English?
Yeah, I would love that too. And I keep meaning to take all of this learning and contribute it back to documentation, and I probably still, I would like to look into that. Right now, it's still the best I've found, unfortunately. But that was very specific to Mitaka, CentOS, RDO, this kind of thing, which was exactly our case. So that article worked for me, but yeah, there's just not a lot of good, solid documentation. And that's what's been a little bit difficult is in that presentation that I showed you from that France OpenStack days, it talks about how adamant they are that there would be documentation. Well, it turns out all that documentation is in the code itself, right? It's documented in the code. So the best bet for you really is to look through the code itself. As a operator, that's not really my strong suit, but that is probably the best resource out there. Sure. We got one more question over here.
It's not so much solving your Ceph problem, but have you considered running a separate Ceph entirely just for Gnocchi itself, just to avoid the
Sure.
impact it has on VMs? Or even kind of a side question, have you tried using the Swift backend and seeing if that has any different performance characteristics?
Yeah, those are actually, separate Ceph is probably not something we could do, but if it's something that someone else can do, I would highly recommend it. We have a storage team that runs our Ceph, and they were good enough to get us a Ceph that we could use for production. It was kind of a dragging them along the way because they're enterprise storage guys, and so getting them on board with Ceph to begin with was a little bit of a challenge. They've fully adopted it now, but to get it like a second Ceph cluster just for them for this would be a little bit tricky, given budgets and everything else. We have talked about just running like a smaller one internal to us, but then you get into my Ceph versus your Ceph, and it gets a little bit messy. We have not looked at Swift directly because from what I had read, the Ceph option was their recommended. And so we kind of had stuck with that because we figured we'd get as good or better with Ceph than we would with Swift. I'm open to trying it though, and we probably will try it. We tried NFS, we tried some other things that were equally kooky, so. Good question though. All right. Hey, thanks guys, I appreciate it.